The first steps in our ML pipeline are data extraction, analysis, and preparation. Given the rather obvious relationships in our dataset, I'm going to combine these into one step. I've created a simple Python script that we will use to analyze and prepare our data. Let's take a quick look at the source. The first block of code opens our TaxiFare CSV and loads it into a Pandas data frame. This will allow us to use a few standard data frame methods to learn more about our data. We're going to focus our analysis on the trip miles, trip minutes, fare, company, and tip rate columns. The next block of code calls the data frame info method. This will provide us with schema-like information for the columns in the data frame. Next, we call the data frame head method to print out the first 200 rows of the data frame, so we can see what our data actually looks like. Calling the data frame describe method will provide descriptive statistics that summarize the central tendency, dispersion, and shape of the data's distribution. The next block of code calls the data frame's correlation method, which computes the pairwise correlation of the columns. This will show us if there are any statistical relationships between the column values. We will use this information to decide which features we should train our model with. Now that we've gained some insight into our data using some standard data frame methods, let's finish up our analysis by creating a couple of scatter plots, visually depicting the relationships between fare and trip miles, as well as fare and trip minutes. The goal of machine learning is to create models that can make accurate predictions when presented with new or unseen data. In order for us to be able to assess how well we've achieved that, we're going to need some validation data that the model wasn't trained on. That's what the last block of code takes care of. Now that we've taken a quick peek at our Explore Data Python script, let's run it and see what we can learn about our data. If we scroll up a bit, we'll see that the results of our call to the data frame info method show us that our dataset contains 31,694 rows. None of the columns have null values, and the trip miles, trip minutes, and fare columns are all floats. The call to the data frame head method shows us a few rows of actual data. No surprises here. The data looks reasonable. Now let's scroll down a bit and look at the results of our call to the data frame describe method. This shows us the min, max, mean, standard deviation, and the 25th, 50th, and 75th percentiles for the values in each column. The call to the data frame correlation method computes the pairwise correlation and returns a correlation coefficient matrix. A correlation coefficient will range between positive 1.0, a perfect positive correlation, to negative 1.0, a perfect negative correlation. Since we want to create a model that can predict cab fares, the row of particular interest to us is the fare row. We can see that both trip miles and trip minutes have a high positive correlation to fare. That makes both of these variables good candidates to be used as features during model training. Next, let's take a look at our scatter plots. The trip miles variable had the highest numerical correlation to the fare variable. Looking at the graph, you can almost see a 45-degree line forming. We can also clearly see that there's some sort of relationship between fare and trip minutes, but it appears to be less defined than the relationship between fare and trip miles. Let's start off by training our model on trip miles. With our Explore Data Python script, we've learned more about our data schema, seen a preview of the actual data, calculated some statistics on the columns, and explored the relationships between the variables both numerically and visually. We also split our dataset into training and validation datasets to be used in the training and validation steps of our ML pipeline.